Okay, so today we're going to wrap up our conversation about strengths of relationships by actually having a conversation about correlation versus causation. So, over the last couple days, we've been talking about strengths of relationships and how I know something is strong, something is weak. So, let's go ahead and take a look at some data, and then we're going to get into correlation versus causation. Okay, so let's take a look at this data. So, tell me what you see in the graph. Is it strong? Is it weak? Is it positive? Is it negative? Can you make a statement about its relationship, about the strength of its relationship? Well, hopefully you see that, yeah, this is a pretty strong relationship. The points are pretty close together. And I see that if I was to draw a line of best fit, I could probably pretty easily draw a line of best fit right through there. Okay. So you might think that this is a positive, strong relationship, just based off of what you see in the graph. Okay. Now, we've kind of talked a little bit about you can kind of make data look however you want it to look. And media loves to use data to kind of twist and cause drama, if you will, and cause chaos. So let's actually take a look at what we're talking about. We're talking about jars of jam and number of CDs sold. So we're talking about does the number of jams of selling strawberry jam sold in New York have anything to do with the number of CDs sold in Florida? Well, it looks like it does because it looks like it's a positive, strong relationship. But in reality, there is no connection. There is no connection. This is what we call causation. Okay, it is not related. There is no correlation between those two. It is just some random things they put together that make it look like there could be. Okay, so it's important to pay attention to what the data says. You can pretty much make anything look like anything, but it may not have anything to really do with each other. Let's look at this next one. What do you see? I see a pretty strong relationship. I see that it's negative and it's strong. Okay. What are we talking about? We're talking about lemons imported to the United States from Mexico and highway fatality rates. So people dying in car accidents. Do those have anything to do with each other? It may look like this is negative because it's going down and there's only 2 points that are off the line, but there is actually no true relationship here. Okay. So that's causation. It's just false data, if you will. Let's look at another one. Okay, so this one, I see that there's all these countries, and I see there's a cluster of them here, and I see, oh, that's definitely positive. I think I can draw a line of best fit right there. Looks like a fairly reasonably positive, maybe medium, because I have my numbers here, and I actually see that they give me a correlation coefficient. They give me an R value of 0.791. So that's a pretty strong relationship. Well, what are we really talking about? We're talking about chocolate consumption and Nobel laureate winners. So what they're saying is there's a correlation between how much chocolate I eat and if I can win the Nobel Peace Prize. Does that even make sense? No, it doesn't. So this again is causation. Okay, it's being impacted by some third-party variable that makes it look like there's a correlation, and there really isn't one. All right, what about these? You have to decide correlation or causation. If I study more, I will do better on the ACT. Remember, your ACT is the test that goes, that helps you, like the colleges look at. It's like your college entrance, like where are you ready for college exam? Well, that one makes sense. So there probably is a positive correlation between if I study more, I'm going to do better on the ACT. Well, how about if I study more, I will read more books? No, that is not necessarily true. Okay, that is not necessarily true because I can study online. I can study with a video. I can study with an audio. I don't have to study with a book. And it definitely doesn't mean that I'm going to read more books. Now, there's probably a correlation there. And we can plot some data and it probably would be positive, but it really isn't going to be a true correlation. It's pushing more towards causation. Same thing here. If I read more books, I will study more. Well, that one definitely isn't true because I can read for fun. And that doesn't mean I'm studying. Now, there will be a correlation there, but doesn't mean that it's a true correlation. It's going to be impacted by causation. What about this one? Cancer causes smoking versus smoking causes cancer. Which one is actually a true correlation? Yeah, the one that's true is the smoking causes cancer. The other one, that's not necessarily true. Smoking doesn't necessarily cause cancer, or cancer doesn't necessarily cause smoking. So that one would not be a true correlation. All right, what about this one? So correlation versus causation, event number 1. I moved to Seattle 3 years ago. Okay, that's the first thing that happened. Event number 2, the Seahawks have done an amazing job and they are winning and getting so much better. Okay, they are winning, they're getting so much better. So since correlation, since one thing causes the other, then they've been improving and doing well because I moved to Seattle, right? No, those two things have absolutely nothing to do with each other. Okay, nothing to do with each other. So remember, just because it looks like data is connected does not necessarily mean that it is true correlation. It could be being impacted by causation, okay, by a third party variable. So just be aware of those things as you're kind of looking at data. We do have a test tomorrow, so we're going to wrap up today. Make sure that your bivariate packet is complete, your bivariate activity, and then I want you to do a little bit of quizzes practice over line of best fit and correlation. Reach out to me if you're having any issues. Otherwise, we're going to wrap up the semester with a stats test.